Okay, this is the second part of the 11.3 notes. Again, you're going to need to look at your paper because this is extremely blurry, I know, but you can see on your paper and just kind of follow along with anything I write in. Now, we talked about an angle bisector. JK here is an angle bisector because it's a ray that cuts those two in half. If JK bisects this big angle, LJM, if it's cutting it in half, then that means those two pieces are equal to each other. So that's why they say, angle LJK is congruent. It means it's the same shape and same size as angle KJM. Okay? You could also say that the measure of angle LJK is equal to the measure of angle KJN. Those expressions are kind of really saying the same thing. They're saying that those two angles are equal. Okay, so let's look at the next thing down here. KM bisects JKL. Measure of angle JKM is 4x plus 6. I'm just going to write it in there. 4x plus 6 degrees. And then MKL, which is the other half, is 7x minus 12. And they want us to find what JKM is equal to. And remember, what they're asking us when they're asking us for JKM is this right here. Now, you might think, well, how am I supposed to know? The thing they told us was that this KM bisects it, so it creates two equal pieces. And if it creates two equal pieces, then we can actually figure out what X is and plug it back in to find JKM. So since those two pieces are equal to each other, we're going to set them equal to each other. 4X plus 6 is equal to 7X minus 12. Remember, we want to get all the X's on one side, and we always move them to the side where there are more of them. So I'm going to move these 4X over to the other side. Remember, it's a plus 4X. So we do the opposite. We subtract 4X. Okay? And so that leaves us with 6 is equal to 3X minus 12. Okay, so if I want to get the numbers on one side, I can move the 12 over. The opposite of a minus 12 is a plus 12. We would want to do that first because it's PEMDAS backwards when we solve. So 3x is equal to 18. If we divide both sides by 3, we get x is equal to 6. Now that's not the answer, but it's going to help us get the answer. Because they wanted JKM, and JKM, they told us was 4x plus 6. So if we plug in x is 6, that's 4 times 6 is 24, plus 6 is 30 degrees. Okay? All right, if we look at the next one, it says QS bisects PQR, and they didn't even give us a picture, so we're going to have to draw it. You're going to have to kind of ignore that little line up there. We're actually looking at this number 2 right here. Actually, I'll use that line. If QS bisects PQR, so let's say this is P, this is Q, and then we have R down here. And these are angles, rays, so they'll go off like this. And we've got a bisector of QS. That means QS is going to cut it in half. So that means this piece and this piece are the same size. One thing that we do to show that they're the same size is I put the same mark on both of them, this little kind of arc that I put that shows that they're equal. Okay? Now, this is PQS is equal to 5y minus 1 degrees, and PQR, now that's the whole thing, so the whole thing, PQR, is 3y plus 12. So let's think about it. If we're trying to figure out what y is here, because they want to know what PQS is, and PQS is 5y minus 1. I can't answer that question if I don't know what y is. So how can I make an equation so I could solve for this? Well, if you think about it, if these two angles are equal, then if this one's 5y plus 1, then also SQR is 5y minus 1. So I could say, well, 2 of those 5y minus 1s would add up to the whole PQR, which they told us PQR is this 8y plus 12. So since they're equal, if I multiply it by 2, it's going to be equal to 8y plus 12. So we can solve for y here. And once we solve for y, we can plug it in and say, well, PQS is 5y minus 1. So in a minute, once we find y, we'll plug it in right here. Okay? Let's come over here and work. Let's simplify each side first. So 2 times 5y is 10y. 2 times negative 1 is negative 2. So we have 8y plus 12 on the other side. I want to get all my y's on the same side. So I'm going to subtract this 8y, move it over here where there's more y's so that I don't have so many negatives to deal with. 10y minus 8y is 2y. So I have 2y minus 2 is equal to 12. And if I want to get y by itself, I could add 2 to both sides first. Remember, you always do the opposite. Some people might think you do the same thing, but you do the opposite, right? So that gives us, I'm going to come over here, 2y on the left side and 14 on the right side. If I want to solve for y, I could say, well, if 2y is 14, to get y by itself, let me divide both sides by 2, and I get that y is 7. Now that's not the answer, but what I am going to do is plug 7 in right here to get my answer. 5y minus 1 would be 5 times 7 minus 1. 35 minus 1 would be 34. By the way, I know I'm going fast. Remember, you can always stop the video so that you can write stuff down if you need to or replay it. I'm just trying to go through it fast so it's not an extra long video. Okay, so we found out that that was 34 degrees. Now, on the angle pairs, we start those notes down here. Adjacent angles are two angles that share a common side. For instance, in this first one, this is the common side they share. Because they have sides that touch, those are adjacent angles. We would call them adjacent angles. Now, a linear pair are two angles that are put down and back to back. They're adjacent angles, so they got this side in common that I'm kind of drawing in right now. But when you put them together, they make a line, so that means that they actually add up to 180 degrees. We could say that angle 3 plus angle 4, try to draw that, is equal to 180 degrees, and that we get lots of problems like that in geometry where we are figuring out angles when they're in a line like that. Okay, this is the top at the next page, and it says tell whether these angles are adjacent and form a linear pair, or not adjacent. So the first one is AEB, which is this, and BED. BED. Those are adjacent, and their outside rays form a line. Right here, right? So these are adjacent and a linear pair. I'm just going to abbreviate. Okay, so I'll do in red the next one. It says AEB, it's right there, and BEC, BEC. Now those are adjacent, but when you look at their outsides, I'll make them darker here and here, they don't form a line, so they're not a linear pair, so we would just put adjacent on that one. Oh, I forgot to turn it on. Okay, so I outlined in green AEB and BEC. Those don't share a side, do they? They're just vertexes stuck tip to tip. So that one's neither. They're not adjacent. They're not a linear pair, even though they're not a linear pair, because if it's a linear pair, the two angles by themselves have to add up to 180, and we've got this whole bit missing right in here. It's not going to be 180. Okay, if we move down to the next diagram, I'll start with green here. Angle 5 and angle 6. I'll just put a dot. Here's 5, here's 6. They share this side right here that I'm highlighting, and their outsides form a line. So these are adjacent and a linear pair. We just want to make sure we understand, what that means. All right, angle 7. Let me do this one in red. Here's angle 7 right here. Angle 7 and SPU. SPU. Now, SPU is a big old angle, isn't it? That doesn't make a line when we look at the outside of it, because the outside of it is like, this is where it starts, and when you put them together, that's where it ends. They're adjacent, they're next to each other, but they do not form a linear pair. They don't form a line, so we would just say adjacent on this one. And I'll switch to black for the last one. Angle 7 and 8. Here's 7. Here's 8. They are not adjacent. They don't share a side. And so if they're not adjacent, they can't be a linear pair anyway. So this is just neither. This is another one of those neither ones. All right, if you look here, we get a definition for complementary angles. Complementary angles are two angles that add up to 90 degrees. So an example is A and B, 37 plus 53. Here's 37 and 53. If we add them up, they equal 90, so they're complementary. Supplementary are two angles who add up to 180 degrees. Sometimes people remember this. If a C for complementary and an S for supplementary, they say, well, it's easy to make a 9 out of complementary and make it a 90. And for 180 for supplementary, if S stands for supplementary, they go, okay, well, you can make that an 8 and make 180. I don't know. If you have trouble remembering the definitions, that's maybe something that might help. Now, supplementary had to add up to 180. And if you look up here, angle A, which is 53, and angle C, if you put those together, they add up to 180. We would say they're supplementary, but we would not call them a linear pair because they're not adjacent to each other. So you can have things that add up to 180 that are not linear pairs, that they don't have to be touching to add up to 180, but they're only linear pairs if they share a side and their outside rays form a line. So they want us to find the measure of each of the following down here at the bottom. They want the complement. Remember, complement means it adds up to 90 degrees. So if this is 59 and I want to find the complement, I would just take 59 away from 90. And that's going to be 31 degrees, okay? If you want the supplement on number 2, the supplement of F, if F is 116.5, supplement means that it adds to 180. So if I want the supplement, I would just say, well, what have I got? I got 116.5 degrees. Let me subtract that from 180. And let me just go ahead and do that real quick. It'll be 5, 3, 6. Is that right? 7 minus 1 is 6. 63.5 degrees. Okay, we're on the back page. I'm going to skip number 3 just to keep this video down to 2 videos. Blank are two non-adjacent lines, non-adjacent angles formed by intersecting lines. Okay, that's vertical up here in this blank. It's vertical angles. Remember, we're skipping the top part, so just skip down there and fill that in and don't worry about that number 3 thing. 1 and 3 here are vertical angles. They're right across from each other. So it's here and here. Those are vertical angles from each other. And then 2 and 4 would be vertical angles from each other. They're right across. As a matter of fact, their sides extend. Their sides are formed by the same lines, or by opposite rays. You can say it a couple of different ways. So down here on this one, number 1 below it, name the pairs of vertical angles. Well, you could say HMJ, or you could call it JMH, and LMK. Those are vertical angles. Let me put an angle sign in front of there. And then there's another pair of vertical angles, and that would be HML. It's supposed to be an angle sign. It's just not coming out very well. HML and angle JMK. And then down on the bottom it says name another pair of vertical angles, and this is the last one on this set of notes. So the pairs, let's number them 1, 2, 3, 4 just for brevity so that I don't have to end up making another whole video just to finish this. 1 and 3 would be vertical angles, and then 2 and 4. Do they look the same? Well, they do to me. I mean, I don't know if they look the same to you, but they are. You can measure them with a protractor and prove it, but they are the same, and you could prove it to yourself. That's it.